Scientists just built a light that breaks a rule every electrical engineer learns on day one. Insulators, materials that are supposed to block electricity, not carry it. That's basically their entire job. But researchers at Cambridge just found a way to power insulating nanoparticles directly with electricity, using something they're calling molecular antennas to grab and channel the current. The result? A completely new kind of LED. One that physics textbooks said couldn't work. This isn't just a cool lab trick. Insulator-based LEDs could lead to entirely new display and lighting technology that's more efficient and works in ways silicon-based LEDs simply can't. Scientists broke a rule to build this.
Your Wi-Fi router might be watching you right now, and there's no camera involved. Scientists in Germany just proved that ordinary Wi-Fi signals can identify specific people with near-perfect accuracy, just by how radio waves bounce off their body as they move through a room. No camera, no microphone, just the Wi-Fi signal your router is already sending out every second of every day. The system analyzes tiny disturbances in the signal, the way it reflects off your body's unique shape and movement, and turns that into what's basically a radio fingerprint. This means identification and tracking could happen through walls, in the dark, in spaces you'd assume were completely private. Your home Wi-Fi could already be capable of this.
Scientists just found a material that acts like metal and glass at the exact same time, and it shouldn't be physically possible. It's called molybdenum oxychloride, and normally a material is one or the other. Metals conduct and reflect. Glass is transparent and insulating, never both. But researchers mapped this crystal's optical properties in detail and found it genuinely behaves like both at once, depending on the direction you look at it. That kind of split personality at the atomic level could unlock technology we've only seen in science fiction, like smart contact lenses and ultra-thin AR glasses that are almost impossible to build with normal materials. A material that breaks its own rules could end up sitting right on your eyeball. Scientists just entangled quantum particles inside a centimeter-sized crystal, and that should not be possible. Quantum entanglement usually only works with tiny, isolated particles, atoms, or photons kept perfectly still in a lab. The moment you scale it up, it falls apart. But researchers at TUVN just detected strong quantum entanglement inside a crystal roughly a centimeter in size, for the first time ever at this scale. That means two particles inside a solid, everyday-sized object are staying mysteriously linked, instantly affecting each other no matter the distance between them, exactly like Einstein's spooky action at a distance. Scaling entanglement up to something you can actually hold could be a massive step toward real-world quantum sensors and quantum computers you don't need a lab full of lasers to run. Scientists just made the quantum world touchable. Engineers just built a material that pulls clean drinking water directly out of the air around you with no power source at all. No electricity, no plumbing, no solar panels. Just the material sitting there, quietly grabbing water vapor out of the atmosphere. The technology works by absorbing moisture from the air, even in dry conditions, then releasing it as usable liquid water, using nothing but the material's own chemistry to do the work. This could change everything for regions without reliable water access, disaster zones, or anywhere clean water is hard to get to fast. A piece of material that makes water appear out of thin air sounds like science fiction, but it's sitting in a lab right now. NASA engineers just took inspiration from a Sahara desert lizard to fix a problem that's been slowing down Mars rovers for years. Sandy, loose terrain is one of the biggest challenges on Mars. Wheels sink, spin out, and rovers can get stuck for weeks trying to cross dunes. But researchers studied how a specific desert lizard moves across shifting sand without sinking, and used that movement pattern to design a completely new approach to rover mobility. The lizard's technique lets it glide across loose sand almost effortlessly, something wheeled or even traditional legged robots have struggled to copy. If this makes it into future Mars missions, a small reptile from Earth's harshest deserts could end up shaping how we explore an entire other planet. Nature solved a problem NASA couldn't.